2019 U-Values question 5, part C. It is proposed to upgrade the thermal properties of the above wall to meet the passive house standard by fixing expanded polystyrene to the external surfaces shown. Basically what they're talking about here is they're going to stick external insulation onto the house to improve the U-value. Given the thermal conductivity K of expanded polystyrene as 0.031, calculate the thickness of expanded polystyrene required to achieve a U value of 0.15 watts per meter squared degrees Celsius. The important thing here is to remember, what are you trying to calculate? So you're trying to calculate the thickness of insulation. How much insulation do they have to stick onto the house so that you end up with a U value of 0.15 watts per meter squared. So it's a thickness value, it's a T value. So we've been given some information in the question. We have to calculate T. We've been given a K value, conductivity of 0.031, and we've been given a new U value of 0.015. So we'll go and write those in to start the question. Okay, so as I said, the big thing, calculate the thickness T. So we're looking for T. They give us a K measurement of 0.031, and they're telling us the new U value for the wall is going to be 0.15. So that's the information they've given us in the question. As I look at these values, the first thing we do is go back and try and figure out, well, what kind of formulas are we going to need. So if we went back to part A of the question, we had three formulas. We've got U value equals 1 over capital R, which is resistance, K equals 1 over resistivity, and R equals T over K. And straight away I see there's a T thickness and a K. We've got both of those, or we've been asked about both of those in the question, so that formula is absolutely going to be necessary. Also, they told us the new U value is 0.15. So in other words, there's a good chance this formula is going to be used. There's no mention of resistivity at all, so there's a good chance this won't be needed. So we're going to write down these two formulas. As I look at the formulas, I'm trying to work out a thickness value. I have a conductivity value, it was given to me. I have a U value, it was given to me. I don't have R, and R pops up in both of these formulas. So that means I'm going to have to work out R, and that's what this question is all about, working out resistance. Basically what's happening is, in the question, we're sticking insulation onto the wall, and that means we're sticking resistance. We're going to stop the heat going out through the wall. So the more insulation you stick onto the wall, the more resistance you create. And we want to figure out how much insulation do we have to stick onto the wall. In other words, how much resistance do we have to stick onto the wall so that our U value ends up at 0.15. That means we need to work out the resistance of the new wall compared to the old wall. Okay, so as I said, we want to stick resistance onto this wall. We need to work out how much resistance we need to stick onto the wall. To do that, we're going to deal with the old wall versus the new wall. And what I mean by that is the wall, or the original wall, versus the newly insulated wall. So for simplicity, we'll just call it old wall, new wall. We need two values, the U value and the R for the old wall, U value and R for the new wall. These we already have done. So when I go back to part A of the question, the U value we worked out in part A was 0.515. And the resistance of the original wall, the old wall, we had worked that out as part of the question, was 1.9395. The question told us that the new U value that we want is going to be 0.15. And we don't yet know the resistance. So that is what we're trying to work out. And we keep going back to the formulas. So I've got U value, I've got R. If I look up here, my formula, I've got a U value and an R. So I come along, U value equals 1 over R. meaning 0.15 equals 1 over R. So we've got a bit of cross multiplication to do. So 0.15 over 1, as we always put it, and we cross multiply. So R multiplied by 0.15 equals 1 multiplied by 1 is 1. Or we want to get on its own equals 1. We're taking this across, so we make it a divide. So 1 divided by 0.15, or we work out in the calculator, is 6.666. And that's the resistance that we need to stick on. So we'll call that R new. The old R, we had that from the start of the question, so the R old, we'll call it, is 1.9395. So this is the resistance the wall is putting up at the minute. This is the resistance we want the wall to put up after it's been insulated. So we want to find the difference between the two. In other words, how much resistance are we going to stick on? So to figure out that, or we just subtract the two. So the big one, 6.666 minus 1.9395, and our R calculation, the resistance that we need to stick onto the wall is 4.7271. Now back to the very start of the question. Originally we said the very first thing we wanted to do was calculate the thickness of insulation. That was our T measurement. So we need to calculate the thickness, and we had our formula here, which was R equals T over K. So go back to the start of the question. We need to work out thickness. At the minute, I now have my resistance measurement. I also have a conductivity measurement. So I can use my formula. R equals T divided by K, and we'll work out T. So R equals T divided by K. The resistance measurement, 4.7271, equals T, which we're looking for, divided by our conductivity, which was given at the very start, 0.031. It was given in the question. And we'll just work out for T. So we'll make this over 1 to make it a fraction. T multiplied by 1, so T equals 4.7271 multiplied by 0.031. T equals, when we multiply this out in the calculator, 0.146. Its thickness, it's in meters. So 0.146 meters of insulation has to be stuck onto the outside, and that doesn't make much sense, but if we divide by 1,000 or just convert it to millimeters, it's 146 millimeters of insulation needs to be stuck on to the outside. That is our final answer. So the thickness of insulation that we need to stick on to the outside of the building to achieve a U value of 0.15 is 146 millimeters.